We're back and we've been looking at the series. So what we've been looking at, well, hey, we've been looking at Service Mesh for the developer workflow. Something that I think we both feel really, really passionate about. And it's something which I think a lot of folks neglect when they're talking about Service Mesh. They think maybe, hey, oh, Service Mesh. A, it's a buzzword, and B, it's of no relevance to anybody. Or kind of, B, I think the key thing is that it's aimed at like an operational tool. So folks don't think of it as something which could be used for developers. And I actually think that service meshes as a developer are a really, really good thing. So the last couple of weeks.
I absolutely agree on that, because like I come from a developer background, and these things that we try to solve when we build these distributed systems, the service mesh actually helps developers out a lot.
Does indeed. And that's why I'm excited about doing this. And I think last week we saw some insights into this. You showed us the Gloo API Gateway, kind of how that means that it's also an operational tool, but actually it's a real benefit to a developer as well. And a lot of comments as well on the live chat saying, well, hey, like, why should developers care about API gateways? And I think we explained some of the reasons why. And actually the element that you necessarily care about could be quite small, but the user experience, which is built into your API gateway, kind of covers a lot of those things. So that's right. I think real nice. And we'll kind of stick the video up there or wherever it is, so folks can watch that. Obviously in the first video, we kind of just had a generic overview of, we were talking through some of the concepts of why these things are important. And again, I encourage, if this is the first time that anybody is tuning in, then like maybe check out that video as well. It's amazing. I'm going to say that, obviously. But what we want to do with this show is starting to dig into distributed tracing, and we'll kind of look at what distributed tracing is. And I think the thing that I'm kind of excited about is I'm going to smash the myth that you plug in a service mesh and distributing tracing is just going to work for you out of the box, because it isn't.
That's true. There are a handful, or maybe a lot, of features that get discussed when we talk about service mesh, and they're discussed in terms of, well, if you use a mesh, you get these things for free. Or you don't have to change any of your application code because the sidecar runs out of process. And when we look at how to leverage a service mesh to help with these types of problems, specifically tracing that we'll look at today, we'll see, like you mentioned, that's not always the case.
Yeah, but we're not all just the bringers of doom, because we're going to show you exactly what you need to do to be able to integrate the tracing into your app. And right. I don't think it's that complicated. It is, it's some stuff, but once you learn it, it's pretty straightforward. And we're going to kind of look at open tracing as a piece of software and Go, because I'm pretty useless at doing anything else. But open tracing, the nice thing, and obviously open telemetry, which is the kind of progression.
Explain what those are, and why would I use one or the other?
So I think what open tracing sets to go about is to unify the developer's API around all of the various different tracing systems. So you've obviously got software as a service like Datadog or Lightstep or Honeycomb. And then you can kind of run your own. So you could use Jaeger or just pure Zipkin inside of your own system. Now, what the open tracing approach say is we want to rationalize all of those different APIs. And we'll kind of get into this in a moment about how the composition of what is a span and what is a trace and all of that. But there is a difference. Now, so if there's an API, having rationalization around that as a developer, it means that if I understand the open tracing API, then I can be successful at implementing into my application code no matter which system I'm using. the benefit of as well is that I get an abstraction. So for example, we're working in dev, we want to just use Jaeger and Zipkin, and we're going to run that locally. But in production, we don't. We want to run Honeycomb, or we want to run Lightstep or Datadog. We're going to go for a paid for solution. Now, if I use a piece of tooling like open tracing, switching out between those various different providers becomes one. It's not quite configuration, but it genuinely isn't far away from just configuration. I don't have to go through and change library imports in all of my application code across all of my microservices. I can do that very, very, very easily. And that's a very good thing. So then there's like open telemetry, right? And well, what is sort of open telemetry? Well, sort of open telemetry is kind of the next step. So kind of you have open tracing, and then there was open census and open metrics, and there was kind of a few different application groups which are trying to solve this problem. So open tracing, the next step is open telemetry. It's the merger of open census and open metrics, I think. Am I right there? I get so confused sometimes, but
yeah, no, I think that's right.
But the APIs are I've been using them in one of my services at the moment. It seems pretty good. They are marked in GitHub as alpha, but I think where we're sort of going, that open telemetry will be the interface that application developers will use when they start to deal with both metrics and traces. Okay, so that's kind of nice, because that means that whether I'm using Datadog and Prometheus, or whether I'm using Datadog and Zipkin, or Influx and Zipkin, or Influx and Datadog, as a kind of a combination between my tracing and my metrics providers, again, I have this one kind of rationalized, sensible sort of abstraction which everybody contributes to and agrees to as the same sort of API that I integrate at that level, which is, it's a really, really a really good thing indeed, I personally believe.
So this is definitely a developer concern, right? This is, if you're building services, microservices, then telemetry, tracing, these are things that you need to do.
Yeah, I think so. And I mean, I think you can kind of comment on the chat. Is there a single person here who's never written a service with a bug in it? And I think if we put hand on heart and we're all honest, we make mistakes. I would actually argue that the mistakes are good, and that mistakes actually help you work fast. The key thing is to make sure you learn by them and you can sort of iterate and solve them. We're going to look at those. Yeah. So we're going to look at tracing. We're going to see how it works. We're going to see some examples of some traces, and I am going to retrofit an existing API with some tracing so I can take you through the various different steps that you're all going to need to go through. And I'm going to attempt to do that.
Before you jump into that, so developers need to worry about this, right? So right. What is the service mesh? How does the service mesh fit into this?
So the service mesh fits into this, and I think we talked about the concept in the first video about distributed reliability patterns. So, sorry, not distributed, decentralized reliability patterns. So the kind of the Hystrix approach is that you would put things like retries, backoffs, timeouts, all of that logic into your application code. Now, when that's in your application code, you can sort of handle the fact that, you can log a metric, or you can create a new span every time you retry an upstream. When you decentralize that, so when it's the service mesh, which is handling your retries for you, it's handling the backoffs and the timeouts, your application code doesn't actually know how many times it's attempted to call an upstream. It just knows whether it gets an ultimate success or an ultimate fail. So when that comes to kind of as a metric, understanding the number of retries or the number of tries that you make for an upstream, or whether an upstream is timing out, it's absolutely essential. But you don't have that control anymore. But the service mesh does, and then we will kind of see that the service mesh also omits those metrics. So it's kind of just, they're there. It's just going an extra layer up. Should we dig in?
Let's do this. Yeah.
Right.
Let's get hands on. Let's get into the code, and then we'll see.
We can see.
We'll
Alrighty. So what I have for you. So I have a multi-tier application, and it's a pretty it's a fake service. But the kind of the composition of it is that there is a web front end, and the web front end talks to an API, and the API talks to a payment and a currency service. So we can kind of see the web talking to the API. This is just a very, very simple graphical UI, but let me just refresh that. So I'm refreshing that. What's actually happening is these requests are flowing over the service mesh. So the web service is making an upstream call to the API, but it's not doing it direct. The web service is talking to its service proxy, its Envoy proxy. The Envoy proxy for the web service talks to the API's Envoy proxy, and ultimately the Envoy proxy then talks to the API service, which is all running there. So that's that kind of standard proxy-based service mesh architecture. So I have tracing embedded inside of this application, and if I kind of refresh here, I'm using Jaeger and I'm using Zipkin as the format. So when a request comes into my API, I'm creating a span. When I call an upstream, I'm creating a span, and the combination of those spans forms a trace. So here's a trace. So let's have a quick look at this. So
before you go on, you said something interesting there. You said you're using Jaeger and Zipkin.
Right.
Can you give a little bit more? Just kind of curious, what is the difference between those?
Yeah. So sort of Jaeger has its own format. Jaeger is predominantly a sort of a data collection. We're cutting off the screen. So Jaeger is a data collection tool. It's a data store which you can use for collecting all of your spans and traces. It also has a nice UI on this for interrogating information around your spans and traces. Zipkin is the kind of the format of the span that we're using. So I suppose it's like a format inside of, in the same way as JSON being a format. So like if you're using Datadog's SAS, Datadog SAS has its own format. And Jaeger, I'm sorry, I'm just trying to adjust my screen for the folks on the video there. I think you should be able to all see all of that now. So Jaeger is just a tool. It's open source. The version that I'm running here, I'm running in dev mode. So I'm literally running Jaeger all in one, everything in a Docker container, the data store, the UI, the Zipkin span collector, all of those things. I could also use Jaeger. I think it works with Elasticache. So if you want a more sort of persistent, a persistent form of storing information, then you can use that too. Obviously, the Honeycomb, Lightstep, Datadog, it's a very sort of similar sort of approach to the problem, that collecting the information, collecting the spans, and then being able to reassemble them into this trace view like here. So what we're seeing on this trace view, and I'm just going to just collapse everything so I can step through it, is we see all of these individual spans. Sorry, somebody's asking for the links. If you just check out oh gosh, can I spell Jaeger? Can I spell it? R-E-A, not Jaeger women's and men's clothing, but I mean, if you need a new jacket, you could check that out.
What about the drink?
The what? Sorry. Oh, the drink. Yeah. But check out jaegertracing.io. I will just paste that into the chat for folks to check out. All right. So what's going on in my trace? So what I can see here is I see my spans. Remember, a collection of spans makes a trace. So this first span is handle request. So I've actually given this created this span, and I've given it the name handle request. You can see that it has some metadata on it. So for example, it has the HTTP that I'll save that story for another time. Response code, and again, I'm adding that through my code, and I'll show you how to do that. And also, I'm adding some just logging information here. So we can see things like the start time, and we see the overall duration. So you can see there that this span is all of this good stuff here, right? But in isolation, that span is a thing. But what I'm interested in is seeing it broken down. So what part of that, all of that operation, which actually amounts to me just refreshing this web page, is taking time, or what part of that is causing errors, or what part is causing retries? Well, I see that because I start digging down into the child spans. So for example, here I can see that I'm calling an upstream. And again, this is a span that I'm creating. I'm attributing it with some metadata, so some tags here. I have call metadata. I'm setting again the upstream, the response code. You can kind of see the sort of start time and the various other bits and pieces there. And come on, browser. Then we start getting into this one here. So you see, we've got another stream, another span. Sorry. So this span, what's actually going on here? Gosh, this is coming from Envoy. So I didn't create this span. The service mesh has created this span for me. So I can see that, we've got a lot of information there. So this is all of the information that the service mesh has automatically added to my trace, which is nice. I haven't had to add it. So I've got the HTTP protocol, the user agent. I can see the method, URLs. I can see upstream clusters and all sorts of information, response sizes.
So that's really nice of the service mesh to do that for us.
Right. Yeah, it saves you a lot of effort. But the important thing is that, and I'm just going to zoom back out there a little, is when you have a retry, in that instance, you're going to see sort of multiples of those calls because it's the service mesh which is actually making those retries. So you see the trace go from your application code out to the service mesh. You're going to see the service mesh adding its own information to that, and then it's eventually going to come back in. So for example, here it comes into my API. So again, I've got that continuation of the trace, and then I go to my API, and from my API, what I'm doing is I'm calling the payment service. So you look at the payment service here, and again, this is the service mesh is handling, it's created that span for me, but then it goes dead. So I know that my payment service API code hasn't created a span. I haven't seen the calls to my currency service, the trace has gone completely dead at this point. If we kind of bounce just back out, well, I mean, if I look at the traces, here, which are reported from the payment service, they exist. So this is the payment service reporting request, but this is disconnected from, this shouldn't be shown as an independent trace. It's disconnected from the web trace. And why is that? Because I've got this magical service mesh, and the service mesh should be doing everything for me, right?
Yeah, absolutely.
Right. Wrong. It's a problem. So let's have a look at how it works. So what we're doing, we have this association. So remember that a trace is a collection of spans. Jaeger is reassembling those spans into this kind of trace, right? So how do you connect the various different spans together? Well, you do it through a sort of a parent-child relationship. So in terms of HTTP, when I make an upstream call, what I'm doing is I'm adding some HTTP headers to my outbound request. And this is the Zipkin specification that we're looking at. And Zipkin is adding these headers, which are going to start with x-b3. So we're going to see things like x-b3 trace ID, parent span ID, etc. So the reason that this is important is that when you receive a request from a service, you're going to check to see if these headers are present, and you're going to add those. You're going to deserialize them, and you're going to use those when you create your own spans. Because then when you create a span, you're adding the trace ID of the parent span, and that's how you can kind of build this kind of hierarchical sort of diagram. So
the application developers have to do that. They have to do this
right
kind of remapping
because the
association.
service mesh can't, because the service mesh knows what comes in and it knows what goes out, but it has no way of tying an inbound kind of request to an outbound upstream call, because internally inside of your application you've got a number of different threads which are operating. So the service mesh, it's not a one-to-one relationship. The service mesh can't automatically create an outbound upstream span and associate it to the inbound request. That's the work that the application developer has to do, and it's not that much work. And actually, I'll be honest with you, you can add so much more information by doing this. I mean, you can add information. You can add your own spans. If you've got a database call, you can create a span for your database call. You can log things like maybe a slow running query or something, which really sort of enriches your view on the world. And of course, with all of the kind of the UIs, you've got the ability to kind of look at duration, so you can search and filter and things like that. It's a very, very powerful tool. So how do we do it? You're all exhausted. I bet you are. It's not actually that hard. So this is a Go microservice. This is our payment service, the one that we were looking at before. And if you kind of remember, our trace goes dead when we hit the payment service. And the reason that the trace goes dead when we hit the payment service is because the application developers who created the payment service, well, they're not passing on that trace ID. There's no kind of parent span correlation going on here. And if we look at the code, all that literally is just happening is that the app developers are just starting a span, and that's causing the trace to get lost, because this start span cannot do an association with the parent. We've got to do that ourselves. I just want to kind of quickly sort of show you what it means to kind of create sort of tracing clients and things like that with open tracing, and the open tracing documentation is excellent. You'll find a lot of information there, but it's not a lot of code. So the setup is I create a reporter, and the reporter which I'm going to use is the Zipkin reporter. I give it the address of the API which is going to collect the spans. In this instance, it's going to be the Zipkin server /API/v2/spans. That's the v2 collection API. And then I create my endpoint, and then with that endpoint I initialize the tracer. Once I've initialized the tracer there, I can start using it to collect spans. So to create a span, I'm going to use this start span function. And it doesn't matter whether you're using Zipkin, Datadog, or anything like that. This code here is going to remain exactly the same. What you change to differentiate between the various different backend sources is going to be the reporter. So I could easily have had a configuration element which automatically switches my application code between Zipkin and Datadog in like 10 lines of code. So I'm creating my span and I'm logging some fields. Now, what I'm not doing is I'm not taking into account that a previous span existed. So how do I kind of go about sort of doing that? Well, what I do is I need to retrieve those XB3 IDs for Zipkin, and I need to decode them and use those when I create my new span. Open tracing has everything sort of covered here. So we can use the global tracer extract method. So that looks like this. So I'm going to create what's called a wire context. And the wire context is going to contain all of my headers for my parent, if they exist. And it's going to be open tracing dot global tracer. So that's what's configured to be Zipkin. And I'm going to do extract. What I'm going to extract is the open tracing dot HTTP headers, and I'm going to extract them from my HTTP request header. So that sort of function there, again, this is a generic function. So whether I'm using Datadog or Zipkin, Datadog's going to use different headers, so is Lightstep. Then this same function is going to work just fine for me, because when I set up that global tracer, what open tracing is doing is it's configuring the various different parameters, such as like how to send data, what the span format is, what the kind of the header format is. So again, I can just write this one generic piece of code. So this is going to extract those B3 headers, and it's going to create a wire context with span context, which is just an open tracing object, and it's just an interface for holding in some data. Now, I'm going to do my good Go defensive coding. I'm going to log an error. So I'm going to say if the error is not nil, then I'm just going to log that out. Now I'm going to log this out as just a sorry, I'm talking and typing. Just the standard debug log, because if I can't extract a trace, I still want to create a span. It just means that there's no parent span. The XB3 headers haven't been set on the parent. So then I start this is how I would start my span if I wasn't going to use the parent span. I can actually just add an additional parameter in here, and I can add my wire context, and I'm just going to use this function here. So it's xct.rpc server option. And let's just have a look at this function here. So what this is going to do is it's basically going to convert that span context into the outbound options that I need to create my span. And for the most part, you don't necessarily need to do anything with that. So start span, it's going to take a name. What is going on, computer? It's going to take the name of the span. So I'm calling this span handle request because I'm very imaginative. I'm adding the parent span context there, which I've extracted from the HTTP headers. And I'm going to log some fields. Now, logging the fields, you can log whatever you want. I'm just logging the service type as HTTP. I could also log, let's have a look. Let's just log log.string. What shall I log? Ooh, gosh. I'm going to call it nick.is. Cool. Okay, because, well, that's what everybody needs in their log files. But I can log anything you want. And again, when you're sort of developing your application code, you log things which are meaningful to the request of the span. So it could be things like you might log the SQL query, you might log some of the query string parameters, whatever you think is going to be useful, right? So that's going to handle our inbound span. So that means that the connection now is going to be complete. But the thing is, what we're also doing is we're calling another upstream service. So if I just build and run this, then I'm going to see the payment service in my trace, but I'm not actually going to see the kind of the currency service listed. Gosh, I can't talk today. It's been a long day. I apologize. So how do I handle that? Well, what I'm going to do is I'm going to create a child span, and let me kind of walk through the steps of creating that child span. So the first thing is I'm going to create the span. So I'm going to call it child span. Never underestimate how difficult it is to talk and speak at the same time. So I'm going to start a new span. And remember, it's exactly the same as starting this one up here. But the difference being is I'm going to give it a different name. So I'm going to call this one call currency. And then what do I want to do with this? Well, I want to associate this child span with this parent span that I'm created, right? So that I get that trace. So how do I do that? Well, again, open tracing. I'm going to do open tracing dot child of. So I'm using a function here, and I'm just going to reference the server span context. So the context of the span which is being created here. And that association there is going to mean that when I view my trace, that these two spans are going to glue together. But I do need to do a little bit more, because what I also need to do is I need to forward the HTTP headers that I received onto my next request, so that when my currency service receives the call, it can do its own global tracing extract on those headers, and then when it creates its spans, it's got that nice association. So we do that by kind of setting the kind of the output. So I'm going to use the ext package, and I'm doing span kind RPC client dot set, and I'm going to set my child span in there. So what is this function doing? So it applies the tag to an existing span. All right, fair enough. The important thing is when you start looking at this, so I'm going to do HTTP URL dot set, and I'm setting again the child span, and I'm just adding some logging information here. So I'm just going to add the URL dot string onto there. And finally, let me just add some more logging. So I'm going to set the HTTP method. And these are just helper functions. Again, child span request dot method. So this this HTTP URL and this HTTP method, it's just a helper function. So I could have literally just used server span log field, child span log fields, but by using HTTP URL and HTTP method, I've got that kind of consistency. I'm going to use that sort of inbuilt enum, which defines the tags there. So that's set up my span. How do I inject that outbound? How do I get those headers, those XB3 headers, onto my outbound request? So if you're kind of used to Go, then I'm using HTTP new request. What HTTP new request does is it allows me to create a HTTP request. I'm specifying the method as a get, and I'm giving it a URL. With open tracing, what I want to do is I want to inject the XB3, the span parent ID and the span ID from my child span that I'm creating within this application code into the application header, the HTTP headers, so that my currency service can pick them up. So we're going to use we're using everything in the open tracing here. So I can just say open tracing global tracer inject, right? Now, remember last time we used extract. Well, this time we're using inject. And inject takes a context, childspan.context. And well, what do I want to inject? Well, I want to inject the open tracing HTTP headers. So the open tracing HTTP headers, that because I'm configured Zipkin, are going to be the Zipkin headers. And I want to inject them from the HTTP headers carrier. Well, this is going to be my outbound request dot header. So I want you to create me the correct XB3 headers. Remember these headers here. And I want you to inject them into my outbound HTTP request. And you can get them from the child span. And it's as pretty much easy as that. This is the proof in the pudding, though. Will this work?
Right. Then we should be able to see.
Let's see.
Everything all linked up.
It might work. It just might. Let's just see if So I'm going to build this application code. I'm just doing a Docker build there. So I'm just doing an all-in-one, building my Go code in a Docker container. And I now have this Docker container. So what I'm going to do is I'm not going to push that to Docker Hub. I'm using a handy dandy little tool which we kind of introduced to you earlier on called Shipyard. Shipyard's given me a local Docker-based Kubernetes cluster. So I'm just going to push my local application container into my Kubernetes cluster. I'm basically copying the Docker container into the Kubernetes container D, so I don't have to push it up to Docker Hub and then back down again. And that's all run. So the next thing that we just need to do is we just need to update our deployment to use the V2. So I'm going to just go back a folder, and I'm going to go into tracing, and I'm just going to kubectl apply -f payments blue. All right, and let's see if that's come up. Okay, so that's all up and running, which is good. Let us now see if we can refresh our UI. So let's just refresh our UI a couple of times and dive over to our tracing. So let's just find the traces. Well, this is looking positive. I now have 15 spans instead of 10, which means I might have got something right, Christian.
You might have. It looks like you did.
Look at that. Isn't that beautiful?
Yeah.
So you can see that I haven't added much code. I mean, I've showed you how to do this in 20 minutes. It's very formulaic, and it doesn't matter which provider you're using because you're using open tracing. I do recommend that people start looking at open telemetry because I think it's the kind of the where the industry is headed. But open tracing is really good right now. It's very well supported. So we can see, so previously, if you remember, we had this payment service, and kind of payment just went, it just kind of went flat. There was no kind of association. We're now kind of seeing that association. So I've got the logs that I added, and Nick is cool. Add that to every one of your spans, please. And we can kind of see the event type, but also what we see here is the outbound. So that child that I added, the child span, you can see that that's also being created, and that's also associated with my system. And now I've got that full picture. It goes through from my application code, creating a child span, to my Envoy Proxy because I'm out into the service mesh, and then I'm into the API's Envoy Proxy, and then into my application code, calling an upstream in my application code, back into the Envoy Proxy, and again back into the payment Envoy Proxy, and back into the application code again. So I've gone that full circle. And I haven't had to do a great deal of information, but I can see very, very visually within this complicated microservice structure, the areas which are potentially running slow. Just seeing a a timing sort of metric inside for my web isn't going to give me much information if my currency service is a thing that's running slow. As it turns out, currency is looking pretty lightning fast there, which is...
And then things running slow and, you know, these latency problems, yes, those are some of the hardest to debug. So it seems like you're able to get a lot of value with a minimal amount of code, right?
Yeah, I mean, it absolutely is a sort of a very little bit of code. As I say, you know, you have to add some code, but it's not a huge amount. Once you kind of get used to this pattern, and again, you know, I'm showing you this in Go, but if you're working in Python or Java or .NET, actually .NET is really nice for dealing with open tracing, just because of the way that .NET can kind of magically do a lot of this code injection for you. The kind of the concepts are the same. The sort of the library is very, very similar in terms of the way that it operates, and the process is absolutely the same. Now, next week, Christian, I am afraid we can't do a show because I'm not in town. I've got to go out of town, but we will be back.
Wow, you saved me, because I'm traveling next week, and I accidentally scheduled a flight during our show next week, and I was going to change it, but if it won't work out on both sides, then let's do it the following week.
Yeah, I'm in Portland next week, so I unfortunately won't be able to run the show. Well, I could, but I'd be from a hotel room and it would be terrible Wi-Fi and it would just be terrible.
Yeah. Yeah.
So we will be back the week after. That'll be kind of February the something or other. 6th, February the 6th, is that
something
right?
like that.
Yeah.
Yeah. I mean, if it's more than 3 days out, I don't know what day it is.
But February the 6th, what we're going to start to dig into is we're going to start looking at Canary deployments, and then we're going to dig into debugging. What I showed you today, I just deployed all of that code YOLO, and I really do not recommend you deploy YOLO when there are wonderful tools like Service Mesh and wonderful patterns like Canary deployments to be able to do this gradually and safely. And we're going to start to show you this. The following
I think it would be cool to, and so this is a little bit of an addition to what we did at KubeCon, which is kind of what we're basing this series of shows on. But I think it would be cool to show the capabilities of a service mesh to do Canary releases, but then talk about some of the patterns that as a developer, you should probably be worried about when you're doing a Canary release or basically it comes down to running multiple versions side by side.
Yeah. And I think we're showing this in logical order as well, because you can't effectively do Canary deploys or dark deploys or anything like that without observability. If you don't understand what's going on in your system, you can't take advantage of those. Debugging, I'm incredibly excited about because I love this pattern, and I'm excited to show you that way that you can remote debug a service running in your production or your test cluster from your local VS Code environment, and to be able to do that. So it's the full cycle. I do my changes, I do my Canary, code ain't working. So let's debug it. Let's find out where the problem is. And we can see some of the wonderful tools with Loop and Squash and how we can do that from VS Code. So been a pleasure as always.
That sounds great. Yes, sir. Job well done on the YOLO deployment there.
Always YOLO. Always be YOLOing. Till next time.
All right. We'll see you.
Catch you later. Bye.